Hi, today we are going to talk about par rate curve, spot rate curve, and forward rate curves. Spot rate curves are usually known as the zero curves as well, and these two terms are always used interchangeably. Okay, I'll illustrate why later. Remember, in the last lecture we spoke about spot rate curve, where I drew the graph of the interest rate versus time. Okay, interest rate R over time. And I said that this is the curve that we usually use to price bonds. So, and the bond valuation formula can be written as C over 1 plus R1 plus C over 1 plus R2 square, and so on, depending on how many coupons that you expect, plus the final maturity par value. Let me use 100 over 1 plus Rn to the power of n. Okay, so this series of R here is being obtained off the spot rate curve. So you can see this is period 1, period 2, and so on to period n. And the corresponding R is here, R1, R2, and so on. So this is what we call the spot rate curve, and it's being obtained through the series of treasury issues. Okay, I also mentioned that when a bond is issued by a corporate, the curve that we use is different. It should be something above the treasury curve. Okay, and this is known as the credit spread. Okay, and this is a curve that we will need to use to price issues by corporates. And there are many different credit curves depending on the industry, depending on the credit rating. For example, a AAA bond issued in the industry of, say, transportation, so they will have its own credit spread, as opposed to, say, BB bond issued by financial companies. You also have its own credit spread. So different industries, different ratings will have their own credit spreads, and we will need to use the individual industry rating for each type of bond in order to price the bond. Okay, for now let's focus on the spot rate curve and ignore the one with the credit spread. Okay, I think a natural way of introducing these various curves, the par, the spot, and the forward curve, is to introduce the par rate curve first, followed by the forward curve, and then the spot rate curve. And I will explain the usefulness of each of these curves. Okay, so let's start with the par rate curve. Okay, let's start with the par rate curve. Par rate curve is the simplest of them all. Okay, remember our objectives. We are supposed to find the values of R that will enable us to plot the yield curve for various maturities. So for time 1, we need to know the value of R, time 2, a value of R. Okay, so this is the objective of us plotting the par rate curve. Okay, assume that we have found a bond 1 year to maturity. So let me write down the bond characteristics. So maturity is equal to 1. Okay, let's say coupon is 5%. Okay, and the price as a 0 is at par, which is 100. Okay, so question is, what is the value of R1? Okay, so this is straightforward. We write the bond formula, bond valuation formula. 100 equal to, okay, so it's 1 year to maturity. In 1 year's time, we are expecting a coupon of $5, expecting a redemption of $100, so it's 105. Okay, 1 over R is the denominator. So straight away we know that the value of R1 is simply 5%. Okay, straightforward. Let me change this a bit to give you the intuition when I have t equal to. Okay, so assume that we have a bond that is 2 years to maturity, paying 6%. Okay, and it's also trading at par right now, so we want to know what is R2. Okay, so we have $100 equal to 6%, so it's paying $6 in the first year. 1 plus R2. Okay, remember that we are trying to find a coupon rate that can be used to discount over a period. Okay, so the coupon rate is the same throughout the whole period. So plus 106 over 1 plus R2 squared. Okay, so if you work out R2 by expanding this whole formula, you find that R2 is equal to 6. Okay, so let me prove to you that R2 equal to 6 is the correct answer. You can write this thing as 6 over 1 plus 6% plus, we write 106 as 100 into 1 plus 6% over 1 plus 6% squared. Okay, so these two terms cancel out, and we have so this will become 106 over 1 plus 6%, okay, which is 100. This proves that 6% is the correct answer. You can also expand this whole equation, but I'm not going to do that. So basically what I've just proved is that when for par bond, the yield is always equal to the coupon. You realize that in the first case the coupon was 5% and the yield was 5%. In the second case the coupon was 6% and the yield was also 6%. So to plot a par curve is going to be very straightforward. Simply use the coupon as the yield. Let's look at Excel, which I've illustrated the par curve over using 3 bonds. So we have 3 bonds. Current observed price is 100. For the first bond, it matures in 1 year. Second bond maturing in 2 years, and the third bond matures in 3 years. And the coupon is as such 5, 6, and 7%. So based on what we have shown just now, the par is the same as the coupon, which is 5, 6, 7%. And if we plot the par curve using these 3 bonds, it's going to be like that. It's going to look something like that. Okay, 5, 6, 7 over the period of 1, 2, and 3 years. Of course, in reality, in practice, the number of years is going to stretch all the way to say 30 years, and the curve will be longer than this. Okay, so you may ask, what's the purpose of the par curve? It's very useful in the sense that, assuming that you're going to lend somebody $100, say for a period of 2 years. Okay, so the question is, what is the coupon that you're going to charge the other person? And straight away from the par curve, you can say that look at 2 years, and you can see, okay, this is 6%. So you're going to tell him, okay, I'm going to charge 6%. Okay, so that's the purpose of the par curve, and it's very straightforward. Okay, let's move on to the concept of a forward curve. Let me use a new worksheet. Okay, so we are going to look at the concept of a forward curve. Before we look at the forward curve, let's illustrate the concept of a forward. Okay, assume that 0. Assume that someone tells you that he wants to borrow $100 in 1 year's time, and he's going to borrow for 1 year, so he's going to pay you at second year, end of second year. Okay, so the question is, what is the rate that you will charge him in 1 year's time? Remember, now we are taking about forward rate, so the question to ask is, what is the rate that you're going to charge him in 1 year's time? So if you draw the graph, right, this is the rate that you'll be needing to find out. Okay, so as at now, right, because you're at t equals 0, you know the rates now, so you can tell from the market that the rate in the 1 year rate, assuming you borrow for 1 year, let's say 1 year rate is 5%, and you also find out that, assume that you're borrowing for 2 years, 2-year rate is say 6.4% per annum. Okay, remember when we talk about interest rate, we should always quote them per annum basis. Okay, so 6.4%, 2 years, what is the effective rate? It should be 6.4 squared. Okay. Okay, so our challenge now is to find out what is F. Assuming that you quote him say 6%. Let's say, for example, you quote your friend 6%. So which means to say that in 1 year's time you're going to pass him money, and in 2 years' time you're going to receive the money. In addition, you'll be receiving 6%. So the question is, are you willing to lend him at 6% in 1 year's time? So let's work out the amount that you will have in 6 years' time. Okay, so you'll be putting your money into the bank for 1 year at 5%, and thereafter lending him at 6%. So effectively, you'll be getting 1 plus 5% at the end of 1 year, and then when you lend him, you'll be getting 1 plus 6% at the end of the second year. Okay, what does this work out into? So effectively, you'll be getting 11.3%. Okay, so you're just subtracting 1 year. Okay, you're getting 11.3%. So question is 6% a good rate to quote him? Apparently, maybe, but maybe not. Let's compare this 11.3% to this 2-year rate of 6.4%. Okay, just now we said that at t equals 0, you can put it into a bank and earn 6.4% per annum, which is effectively, okay, %13.2%. Okay, which is more than 11.3% had you lent him at 6% in 1 year's time. So you wouldn't want to lend him at 6%, right? Because you can earn more when you put into a bank. Okay, so let me cut the whole story short. The rate that you will be lending him basically needs to be a rate which equates the rate you'll be earning if you put the money into a bank now. Okay, so basically the formula to calculate such a rate is as follows: 1 plus the 1 year rate, which you know, multiplied by 1 plus the forward rate, which you're trying to find out. Okay, must be equal to the rate that you know currently for the full of 2 years. Okay, 1 plus 6.4% to the power of squared. Okay, so you simply work out this whole equation to obtain F. And eventually you obtain F to be equal to 8%. Okay, so this is the concept of a forward rate, and it's given by simply finding the full year's effective rate divided by the rate that you know up to the forward. forward period. Okay, so that's the concept of a forward. So why do I want to talk about forward? Because we're talking about plotting the forward curve. Let's look at the bond valuation again. Okay, when you value a bond, I'm going to write down the formula again. 1 plus R1. Okay, so this is R1 plus C over 1 plus R2. Okay. Oh, sorry. This should be time. Okay, so this is 1, 2, 3, and this time, and this is interest rate. Let's call it U. So this is R1, R2, Rn. Okay, so 1 plus R2 squared plus C plus 1 plus R3 cubed, and so on. C over 1 plus Rn to the power of n. Okay, remember we talked about forward rate just now. So basically this expression where we express 1 plus R2 squared. R2 is the annual rate up to year 2. Okay, so we can express this as 1 plus R1, which is the rate up to year 1, multiplied by 1 plus forward rate as at year 1. Okay, so remember just now we went through this. So let's say we have R1, 0, and we have R2. Okay, we have R2 here. Okay, so this one, okay, this one should be period 1, period 2. We have R2 here, we have R1 here, then we have F1 here. Okay, 1 plus R2 squared is equivalent to 1 plus R1 into 1 plus F1. Okay, so our objective in plotting the forward rate curve is to get all the F1 for year 2. F1 as at year 1, F1 as F2 as at year 2, F3 as at year 3, and plot the forward curve. So we have year 1, year 2, all the way to year n, and then we plot the F1, F2, and so on. Okay, so that's the forward curve, and we do so by getting the bond prices for different tenors. Let's look at Excel for an example. Let me hide the par curve. Okay, assume that again you have 3 bonds, bond 1, bond 2, bond 3, maturing in 1 year, 2 years, and 3 years, and they have such coupons. Okay, what is the forward curve? Forward curve for year 1 is straightforward. It's simply the, let me write down the formula. Okay, so you just simply equate the price to the par value plus coupon at the end of year 1 divided by the forward rate. So work out this equation and you get the forward curve. Maybe I'll write it down. Okay, so for year 1, assuming that you have a bond that says you are having 90, is being quoted as 98 currently, and is paying 5%. Okay, so at the end of 1 year you're getting $105, and you're asked to solve for R. Okay, so So this is a straightforward equation. You can solve for R. R will be 7%. Okay, let's look at the second bond. Currently quoted at 96, maturing in 2 years, and is 6% coupon. So what is the forward rate as at the end of year 1? Okay. So again, we are trying to find this one. So this one is quoting 96, 6%. 96, 6%. Okay, 1 plus R1, which we have already solved just now, is 7%. Okay, so this is 7% plus 106 divided by 1 plus R1, 7%, into 1 plus F1, okay, which is the variable that we are trying to solve. So simply solve this equation to obtain F1, okay, and F1 is obtained as 9%. And similarly for bond 3 is using the same concept. You can solve for bond 3, and I won't be going through and obtain 9% for the bond 3. And just plot the curve, and the curve will be something like that, showing the time on the x-axis and the yield on the y-axis. Okay. So again, this is useful in the sense that, you know, when someone says that they want to borrow X number of years into the future, okay, you can easily use this curve and quote the person the yield that the market yield. Alright. Okay, let's move on to the spot rate curve, which is the curve that is most commonly used. Okay, let me look at the first chart that I've drawn. Okay, so let's look at the formula again. Spot rate curve is simply the curve that allows you to get all these R values. Okay, and then you can simply plug it into this formula to obtain the price of a bond. Okay, so again, let's look at the relationship between the spot rate curve and zero coupon. Okay, assume that you have a zero coupon in, say, that matures in 1 year. What is a zero coupon? The zero coupon is, as the name suggests, a bond that doesn't pay any coupon. And yeah, so you may ask, why does anybody want to invest in something that doesn't pay? The reason is because the bond is being quoted at a discount. And so assume that the bond is quoted at 98 now, and at the end of the maturity you can get back par, which is $100. So of course, if you look at such a payout, you'll be getting $2. Okay, so $2 is your profit. And if you translate into a yield, how much is $2? So assume that this is 1 year. In a yield format, it will be something like $2 over 98, because 98 is the amount that you come up with today. So this will be something like, I don't know, 1 point something 9 something. So it will be something that is lesser than 2%, simply because you don't come up with $100 now, you come up with $98 today. Okay, so this is the concept of a zero coupon bond. And if you compare the how we calculate the yield of a zero coupon bond is so much more straightforward, because there's no need for coupons to complicate the whole picture. If you assume that this is t equal to 2, okay, so the yield is simply 100 divided by 98. Okay, because we're talking about 2 years, this will be the returns over 2 years. So you have to take, okay, square root of this whole term minus 1. So this will be the yield per annum. We are always trying to express it as a per annum basis. Okay, so this is a zero coupon yield. So if for a spot rate curve, if you happen to have a series of zero coupons all the way up to 30 years, you'll be perfect. Okay, because the formula is simply just 100 divided by the price today to the power of 1 over number of years, okay, minus 1. So this will be simply the yield of a zero coupon bond up to maturity of n years. So just plot year 1, year 2, year 3, and then obtain all this R. Okay, so it's R1, R2, and so on, using all the zero coupon. And then this will be the spot rate curve of using all the zero coupons. Okay, this is straightforward, provided that you have zero coupons all the way to say 30 years. Unfortunately, in the market, there's zero coupon bonds are usually short dated up to say 1 or 2 years, so you don't have the luxury of using zero coupons to plot the spot rate curve. So what do? Okay, this concept is actually very similar to what we did for the forward rate curve. Let's look at an example. Assuming that we have a series of 3 bonds. The first one is a zero coupon. Okay, so the spot rate curve for the first one is simple. Simply $100 divided by the current price minus 1 is 0.94. Let's move on to the second bond. Okay, second bond. I'll write down the formula. Okay, so for the second bond, what we have here is the observed price 96, coupon of 6%. 96, coupon of 6%. Okay, for the first year, you'll be getting $6. Okay, and we discount at the spot rate that we obtained previously of 6%. Second year, you'll be getting $100 plus the 6% coupon, and you'll be discounting at a rate that we are trying to obtain. Okay, so this is the spot rate for year 2. And I mean, if you think back about how we did the forward rate curve, this expression is simply 1 plus R1 multiplied by 1 plus the forward rate. Okay, so in a way, the forward rate curve and the spot rate curve is very much interrelated. So for the forward rate curve, simply solve for the spot rate, simply solve this equation for R2, which I've done here. R2 is equal to this expression, which will result in 8%. Okay, similarly for year 3, I've obtained it to be 9%, and I can write it down as just to be clear. Observed price 95, coupon 7%. So 95, 7%. Okay, 7 over 1 plus 6% for the first year. 7 over, what is the spot rate for the second year is 8%. 1 plus 8%. Remember to square it, because you are going to discount 2 years, plus 100 plus 7, okay, 1 plus R3. So this will be the term that you want to solve in this equation, R3. Okay, I've obtained R3 to be 9%. So using this 6, 8 and 9% over a period of 1, 2 and 3 years, you can plot the spot rate curve. And yeah, so as I mentioned, it's useful for pricing bonds, treasury bonds, in the sense that when you have a new bond, new issue, simply use this curve, plug it into the formula, and you obtain the price of the bond. Okay. Finally, I just want to add what is this discount column for. It's nothing fanciful. It's just the factor that you need to multiply by a coupon. Okay, so we can see that. Let's look at this formula. We can see that this term is simply 1 over 6 multiplied by 1 over 1 plus 6%. Okay, let me do it in another color. Okay, so this is simply 6 multiplied by 1 over 1 plus 6%. This is simply 106 multiplied by 1 over 1 plus r squared. Okay, and this one is simply 107 multiplied by 1 plus r3 to the power of cube. So this discount rate is simply 1 divided by 1 plus the spot rate to a number of years. And why is it useful? It's nothing much except that instead of dividing, we are multiplying. So it simply tells us, okay, in 1 year, let's say you are given $1, it's worth 94 cents today. And similarly for this one, if you are given 1 year, $1 in 2 years, it will be worth 85 cents today. Okay, so that's the concept of a discount rate. Okay, so another a commonly used verb to describe the way that we have done this spot rate curve is called the bootstrapping. And what it means is simply we are using the interest rate that we obtained for the previous years to obtain the next period's interest rate, which are illustrated just now. Okay, that's all for today. I'll continue next with further concepts in the bond space, in particular concepts relating to durations.